Okay, let's solve example where for the given function f at x you need to determine where second derivative is negative, where function is concave down. Okay, concavity is about second derivative. Second derivative is positive, function is concave up. Second derivative is negative, function is concave down. I remind you summary here. So that you need to know the signs of the second derivative. In other words, you do the sign chart for the second derivative of the function f at x. So rewrite function f at x in the view that is easy to take derivative. For example, x in 4 over 2, I write as 1/2 times x in 4. Coefficient 0.5 I also convert to 1/2. After that, you take derivative, so you will get 1/2, 4x cubed from here, 1/2, 3x squared from here, 9, and 2x from here. When you calculate the coefficients, you will get 4 over 2, that is 2, 3 over 2 is in here, 9 times 2, that is 18. Now, based on the first derivative, you need to find second derivative. You differentiate this expression now. You will get 2 times from here 3x squared, from here 2x, and derivative of 18 times x will give you just 18. Now you know second derivative of the function. How to do the sign chart? You start from the same thing as for the first derivative. You make it equals to 0 or check where second derivative does not exist. Second derivative is quadratic function here, so it exists everywhere. So the only case that you need to do is make it equals to 0. So let's do second part. I have quadratic function 6x squared minus 3x minus 18. I can see that there is a common factor 3 in here. I can divide by this 3, so I have quadratic equation 2x squared minus x minus 6, that is 0. To solve quadratic equation, let's use quadratic formula. Negative b, negative negative 1, plus minus square root, negative b squared, negative 1 squared, minus 4ac, minus 4 times this coefficient times that number, negative 6. So altogether, under the root, you will get positive 1, and from here you will get 4 times 2, that is 8, 8 times 6, that is 48, positive because both signs are both negative, so the result will be positive. 1 plus 48 will give you 49. Square root of 49 is 7, so in the top I have 1 plus minus 7, in the bottom I have number 4. So with the plus, the solution will be 1 plus 7 over 4, that is 2. And with the minus, solution will be 1 minus 7 over 4, that is negative 6 over 4, that is negative 3 over 2. So now I have 2 points where second derivative is 0. I need to plot those points on the number line. I have negative 3 over 2, so it will be on the left side. And positive 2 will be in the right side. Remember that this is about second derivative of the function. Now, how to determine sign of the second derivative for each interval? Checking points. The same process as for the inequalities. Before negative 3 over 2, this is negative 1.5, right? So let's take negative 2 in here as a checking point. If I take checking point negative 2, I need to plug into the second derivative of the function. Second derivative. Second derivative is right here. You can use this form if you want. If you plug in checking point negative 2, what you will get? Six times negative 2 squared minus 3 times negative 2 minus 18. 6 times 4, that is 24, minus minus plus, so it's going to be plus 6. So you will get positive 30 minus 18, the result will be positive. Now let's talk about checking point 0. If I plug in 0 to the second derivative, I will get 6 times 0 minus 3 times 0 minus 18. That is for sure negative. So here I have negative sign. Now, let's do checking point for the interval from the right side of the number 2. I need to erase it here. Second derivative, let's say it's the point 3. So you will get 6 times x squared will be 3 squared minus 3 times 3 minus 18. So here I have 9. 3 times 3 is 9. 6 times 9, 54. 54 minus 9 minus 18, for sure it will be positive. So here we will have plus. Now we have sign chart for the second derivative of the function. Based on the sign chart for the second derivative, you can determine concavity of the function. So below, please draw how the function f at x looks like for yourself. Second derivative positive, so the graph looks like this. Second derivative negative, the graph looks like that. And original question was about where the function is concave down. Function is concave down on this interval. On the interval from negative 3 over 2 to the positive 2. Well said.